Good day, sir. I am the cadet Abarques Christian Joy, and we are Group 1. And these are my group members: Arman Nel Justin, Cantona Reggie, Codrilon Christian Ed, Contento Luis de los Santos Unicis, Dulinte Von Joshua Villahermosa, and Domdom Christopher Ivan. So our given topic, sir, which is explain the effects of wind, current, squat, shallow water on ship handling while maintaining safety of navigation. So first topic, sir, which is effects of wind on ship handling. So wind and current are usually associated as a both being force not under control of the ship handler. The two forces have however a different effects on the ship because of the difference in nature of the two. When the ship is affected by the wind alone and moves through the water, the hull meets underway resistance when on the other hand, the ship's motion originated from the current, there is practically no resistance of the above water area to air, as water is 800 times denser than sea level atmosphere. Current must by nature have considerably stronger effect than wind, especially on loaded ships. Current has a direct effect of the underwater part of the ship and an indirect effect expressed in the momentum after the ship alters course or comes out of the current when the ship will carried momentum in the direction of the current that the ship was previously subjected to. So the effect of wind and current. Whereas the effect of the wind on the ship has to be considered with respect to the pivot point current affect the freely moving ship as a whole, and consequently its effect it is on the center of the gravity. However, when we try to keep the ship stationary relative to the ground, we must arrest the ship's movement and let the ship make speed through the water contrary to the current, in which case the ship meets underway resistance. So all freely moving ship not being subjected to wind and dead in the water have the same speed as the current, what whether the ships are big or small, loaded or light ship, not freely moving as ships at anchor or moored, are subjected to pressure exerted by the current pressure which is directly proportionate to the exposed underway area and the square of the current velocity. So, in a strong tide we see that the ship at anchored or moored to a single point and heading into the tide. When it is nearly slack water, ballasted ship will be moved off the affected by wind while the loaded tanker still remain heading into the tide. So, when we approach the monobuoy with the ballasted tanker and wind tide condition, the direction of the loaded tanker moored in single point nearby gives us an indication of the direction of the current. However, the heading of the ballasted ship after having been tried to up to the buoy may be quite different from the heading of the loaded ship. So that would be all, sir, for my given topic, sir. Thank you.
There are two effects of wind on ship handling. The following effects will now be experienced. So the two effects of wind on ship handling are the turning force and the wind force. So the turning force will now develop a turning moment about P as shown in the picture. So the tending to turn the vessel into the wind again. So head to wind, therefore the vessel is course stable, provided that she maintains headway through the water. So next effect is the wind force. So the wind force will also develop sideways for force on the vessel away from the exposed side. The wind force depends on wind age, wind velocity, and wind pressure. The angle between apparent wind and heading wind pressure is proportional to wind velocity squared. So, if the ship has a large trim by the stern, W will be further forward with a reduction or even loss of core stability. So, this can sometimes result in a rapid and violent loss of control, or it can be an accident.
Vessel making headway through the water and with the wind directly astern, P is forward a long distance from W, which is well up. A comparatively small change in relative wind direction will move W forward. However, W will still some distance above P. So the following effects will now be experienced. A. The wind force will develop a strong turning moment about P, tending to turn the vessel's stern further away from the wind. And B. The wind force will develop a sideways force on the vessel away from the exposed side. Making headway with stern to wind, the vessel loses core stability and is difficult to steer. This effect is greater when there is also a following sea or swell. But if the ship has a large stream by the stern, W may move forward, and loss of core stability may be generally less pronounced, but is still a potential danger.
Effect of current on ship handling. A feature of any river berth is the current. It is common for a river berth to lie in the same direction as the prevailing current so that the current can assist the berthing. In this case, a berth can be approached bow into the current in order to give the advantage of relatively high speed through the water with a reduced speed over the ground. Consequently, steerage at low ground speed improved by the good water flow over the rudder. The ship will be easier to stop. Another advantage of berthing into a current is that it can be used to push a ship alongside, position the ship off the intended berth but at a slight angle towards it, then allow the current to produce a sideways movement of the ship towards the berth. Masters should note that currents are usually complex, with varying rates at direction that can change hourly. For safe navigation, local knowledge is essential. A ship making headway into a current but stop over the ground will have a forward pivot point. Berthing in a current. Berthing with the following current is difficult since the ship must develop stern weight through the water in order to be stopped over the ground. In these circumstances, control of a single screw ship will not be easy. Use a tug to hold the stern against the current. Care is needed when berthing into a current because too large an angle between the berth and the direction of the current will be cause the ship to move rapidly sideways. Unless corrected, contact with the berth may be unavoidable. If during berthing the bow's angle to the berth is overcorrected, then the ship could move away from the berth as the wedge of water between ship and berth become established. This may cause the ship's stern to strike the berth. Once alongside, care must be taken to prevent the ship dropping astern before backspring and headlines are set.
So here are the points to remember or things to remember in berthing in a current. So first is that close to the bank, a counter current flows in opposition to the main river or to the main current in several places. So this knowledge can only be obtained through local knowledge. So next is that the current varies with water depth and different portion of the ship's hull. So a big deep draught ship might suffer varying current effects. So it is necessary to be cautious or need to be extra careful. So next is that when the ship is near to the berth in the head current, the flow inshore is constrained. So when the ship is exposed to interaction forces, so the ship might be drawn into or pushed out from the berth as a result of this pressure. So local knowledge will aid in the prediction of this occurrence. So next is that as speed decreases, be cautious that the higher fraction of the ship's vector attributed to the current does not cause the ship to approach obstruction. Lastly, always establish a large provision for current expenses. So its influence on the ship's grows as the ship's speed decreases. So it is frequently impossible to undo a berthing error. So keep in mind that the current forecasts are just that. Forecast and meteorological circumstances may result in a higher or lower rate than expected. So any substantial anomalies will usually be reported by the local VTS information. So
Effect of a squat in a ship handling. So the squat effect is the hydrodynamic phenomenon by which a vessel moving quickly through a swallow water creates an area of lower pressure that causes the ship to be closer to the seabed than would otherwise be expected. So sometimes the squat effects, and when the ship moves through the shallow water, some of the water is displaced, rushes under the vessel to rise again at the stern. Therefore, this decreases the upward pressure on the hull, and it is making the ship sink deeper in the water than a normal and a slowing vessel. So usually, the parts of the vessel will be affected by the squat is the bow. So this will result in trimming forward because of the squat of the vessel. So sometimes the tendency of the bow is obstruct to the water flow is related to the block coefficient of the vessel.
I'm Cadet Dumdum Christopher Ivan. Effect of shallow water on ship handling. As hull move through shallow water, the area which displaced is not so easily replaced by surrounding water, therefore leading to a state of partial vacuum as a propeller and rudder are still working. The vessel takes up longer to answer her helm and respond to engine movement, becoming sluggish. Next, in these circumstances, vibration will be set up and it will be extremely difficult to correct a yaw or share with any degree of rapidity. Next, at normal speed, it is found that steering becomes erratic when the depth of water is equal to or less than 1.5 times the deepest draught. A vessel drawing 8 meters maximum draught will develop unsteady steering in water of depth 12 meters or under. Next, when a ship nearing an extremely shallow depth of water, such as shoal, she is likely to take a sudden sheer first toward it and then violently away. This is called smelling the ground, and the movement of sluggish ship may suddenly become astonishingly lively. Next, due to the fact that the water displaced by a hull movement through shallow water is not easily replaced, the bow wave and stern wave of the vessel is increased in height, Further, the trough, which normally exists under the quarter, become deeper and after part of the ship is drawn downwards toward the bottom. By reducing speed, the wave heights and true depth will be diminished and the vessel will not therefore close the bottom or squat. The speed of a vessel moving in a shallow water should always be moderate. If the speed is increased, the keel will close with the ground and the ship will shear about unpredictably. If the bow wave and stern wave are observed to be higher than its protected speed should be reduced, but not suddenly. If the speed is taking off rapidly, the stern wave will overtake the vessel and cause her to take a shear which in a narrow channel could be disastrous.
Good day, sir. I'm Cadet Condrillion and I'm going to report about the effect of shallow water on ship handling. So these are the effects. So handling, bow wave increases. So that's one of the effect of ship handling in shallow water. The maneuvering becomes sluggish. Second, the third is the engine load decreases. Fourth, the ship's speed over water reduces. Number 5, stopping distance and time increases. 6, the turning circle increases to a great extent. 7, the rolling and pitching reduces. And the last is the ship may start to vibrate. So these are the effect of shallow water in ship handling. So, effect of shallow water on turning the ship. So, the shallow water affects the maneuverability of the ship considerably. The maneuverability decreases, which, amongst other things, manifests itself in a substantial increase in turning circle of the vessel or required bend radius. So, in shallow water, while turning your ship or vessel, the rudder is less effective in shallow water. So that is the effect of shallow water in turning your ship. That is all for my report, sir.